So now we're going to start this second half of the Paleozoic. So we're going to look at the late Paleozoic. So we're going to see in this section, we're going to see some pretty cool stuff. We're going to see the last two mountain building events of the Appalachians themselves. And we're going to see the evolution of some pretty cool organisms as they start to evolve with life on land. So starting in with question number 1 on your worksheet. The late Paleozoic consists of 4 time periods, especially in the United States. We have the Devonian, Mississippian, Pennsylvanian, and Permian. Remember, everywhere else, the Pennsylvanian and Mississippian are combined with the Carboniferous. But here we can see a distinct difference between the bottom of the layer and the top of the layer. So here in the late Paleozoic, we're going to start to see large land plants come around all over the place, and big vertebrates. We're going to start to see lots of amphibians and reptiles start to come around. And of course, because we're going to have lots of plants, we're going to start to develop swamps. So we're going to start, for the first time, start to see lots of coal getting deposited on the face of the planet. So as the late Paleozoic starts, we can see that our continents are fairly fragmented. We've got Gondwana still together, and of course we've got Laurentia and Baltica that have combined, right, as we saw in the Taconic orogeny. The Caledonian orogeny is still going on, which is, remember, just the extension of the Taconic orogeny. It's just where Baltica is now colliding up there with Greenland. But as we can see, as we're in the Devonian, sea level's fairly high. We've got shallow marine sitting across most of North America, most of Laurentia. We've got this big dry section, right, sitting right there in the center of Laurentia. And what we see here is all along this whole area, we've got lots of reefs and carbonates, which tell us, moving into question 2, that during the Devonian, we have a very warm and wet climate for 2. And the evidence that supports this is that we see reefs all over the place. So these reefs are definitely telling us we are over the equator and that water is nice and warm. Now, we're going to move here into question 3, but we're going to start to see our next orogeny come around. So our next orogeny, question 3, is going to be called the antler orogeny, which is, let me flip the page here. The antler orogeny is basically North America, or Laurentia, colliding with a volcanic arc. So remember, a island arc is created through ocean-ocean subduction, where we have these big volcanoes that are sitting out there in the ocean, and they're tall enough so they actually look like islands. So question 3, the antler orogeny is going to occur out in the west. So we're going to start to see our very first mountain building of question 3b, the Rocky Mountains. So that's actually really pretty exciting. We've only seen mountain building occur out in the east so far, right, with the Appalachians, with the Grenville orogeny and with the Taconic orogeny. But now with the antler orogeny, for the very first time, we're going to see mountain building out of the Rockies. So basically what we have here is we've got this really large island arc that's going to come in and collide. And what I want you to remember is an island arc isn't one single volcano, it's a line of volcanoes. So it's like a line of linebackers coming in and colliding with the continent. So it's really going to start to buckle the continent and start to create mountains that we're going to see there. The next orogeny that's occurring is happening basically at the same time as the antler, but it's occurring out in the west, or excuse me, in the east, and this can be a little bit complicated. So what we can see here down in this picture, I want you to look, is we've got Laurentia here and Baltica, right, that have collided. That was the Taconic. We've got the Taconic mountains all along here. But what we see are these islands that are coming in, these little microcontinents, and it's going to, we call those the Avalon terrain, and they're going to come in and collide. But what's really interesting is they're not coming in straight. As you can see, they're kind of coming in at an angle. So what's happening is it's really kind of occurring like as a baseball player kind of slides into home base. What's happening is these islands are kind of sliding in and colliding with North America. So question 4, the next orogeny that's going to occur out in the Devonian is going to be the Acadian orogeny. And the Acadian orogeny, again, is just between Laurentia and these bits of microcontinent. So again, question 4, we've got the Acadian orogeny. In the north, we still have the Caledonian orogeny. That's 4A that's occurring. So again, I just want you to realize that. And then in the east, we've got our Acadian orogeny, so the Avalon terrain that's coming in. So like I said, the collision for C was very similar to a baseball player sliding into base. So we've got these islands that are kind of coming in and smearing their way across, making a very small mountain chain. Doesn't make very big mountains at all, just nice small mountains. Now for 4D, what's really interesting is Baltica is really now collided in and stuck onto North America. So as a result, we're going to now start to call Laurentia Russia. Because we've got Baltica and Europe collided on there. So we don't just have Laurentia, we've kind of got a mini supercontinent like Gondwana, but obviously not nearly as large. So sea level at this time is pretty interesting. We saw at the Silurian we have a glacial cycle that's occurring, so sea level had regressed. But for question number 5, we're going to start to see our next transgression. And here you can see we've got the Acadian mountains all through here, and we can see sea level is pretty high. Here we've got this nice dry surface over here in Ohio, but over here where this purple is, we've got deep water, and it's going to get shallower as I get closer to the mountains. So question number 5, our next lost sequence is going to be the Cascasian sequence. And of course it's going to look similar to everything that we've seen. Nothing is going to be unique there at all. So after the Acadian, moving into question 6, after the Acadian orogeny, we start to see lots of carbonates getting deposited. Carbonates being, again, limestone, so showing us we are over the equator. And then on top of that limestone, we get clastic material. So remember, clastic materials from the erosion of the mountains. So over here, we've got this nice big Cascadia seaway sitting there. And we've got this nice big deep sea. We're depositing lots of carbonate sediment. And then as the Acadia Mountains are eroding, right, we're going to start to get the deposition of all of that clastic sediment sitting in there. And mostly it's going to sit in this area called the Foreland Basin. So we've basically got this area that's depressed right below the mountains, and it's going to catch all of that sediment. So 6A, all of the sediment tends to be red. So of course that color red is going to indicate lots of iron that's in there. What's really interesting is this clastic wedge material that's going to get deposited in this basin. Today we use to build brownstone buildings. It actually, if you ever find yourself in New York or Chicago and you see all of these red brick buildings, that's all from this time period, from the Acadian. Now, as I said, as we're depositing this clastic wedge material, if I move further west, as you saw, let me scoot back here. As I move further west, the water starts to get deeper. So in that purple area, we start to deposit what's called the Chattanooga Shale. So question C, right, 6C, the Chattanooga Shale was deposited. It's a black shale, so this is deep marine. It's deposited further west of the clastic wedge material. So it's deposited in this very stagnant, oxygen-deficient water, and that's what gives it that dark color. So remember, anytime I see black in my rocks, So it's got a very high organic content. And the only way I can get that organic content that high is if I am in very oxygen deficient water. Now we've been talking about these big basins that form, and during the Devonian we have a very important basin that forms, and that's the Williston Basin. The Williston Basin is fairly large. It's this whole area that's in orange there. And it forms the same way as all the other basins. But question 7, the Williston Basin today is very important because most of the petroleum that we use, all of the hydrocarbons, are found in the Williston Basin. And this is where all of the fracking is going on today. This is the reason why our gas prices are so cheap, is because of the Williston Basin. So the Williston Basin is important because it contains most of our oil and gas that we use today.